How bunker bombs work. Bunker bombs, or bunker busters as they're also known, are essential for attacking military facilities that otherwise would almost be impossible to attack. These facilities could be command centers, ammunition depots, or research labs, but whatever they are, they're usually massively important, which is why they've been reinforced either underground or behind huge amounts of concrete. So, to be able to attack these bunkers is a massive advantage to the aggressor. This is how the bunker bomb was born and how they work. Before we look at this, just a quick reminder to give this video a thumbs up if you're enjoying it, and also to subscribe for more videos just like this one. But now, back to bunker busters. Bunker bombs are weapons that penetrate deep into the earth or right through a dozen feet of reinforced concrete before exploding. When they do explode, they can take out key targets essential to winning a war. Let's see how they work, and first, let's look at why they were needed. In the first Iraq War of 1991, intelligence from Allied forces suggested that there were several underground bunkers that needed to be destroyed. The problem was that there were no munitions at the time that would be able to penetrate deep enough to make an impact. There was then an intense research and development phase to develop a weapon that could. It was so intense that it only took a few weeks for a prototype to be delivered. It had a few key features. Its casing consisted of around a 5-meter section of artillery barrel with a diameter of 37 centimeters. The artillery barrels were made of extremely strong hardened steel to withstand the repeated blasts of artillery shells when they were fired. Inside this barrel was what does the damage once a target has been penetrated, nearly 650 pounds of tritonal explosive ready to go off. Tritonal is a mixture of 80% TNT and 20% aluminum powder. The aluminum improves the crushing effect of the TNT, or the speed at which the explosive develops its massive pressure. This effect makes the blast 18% more powerful than it would have done otherwise. At the front of the barrel, there was a laser homing device. This makes sure that the bomb hit a laser that is being shined onto the target by someone on the ground or in the bomber. There were also fins present, which helped guide the bomb into position. This makes up the complete bomb, which was known as the GBU-28 or the BLU-113. It's 5.8 meters long, 36.8 centimeters in diameter, and weighed in at an impressive 1,996 kilograms. So this is the bomb, but how does it work? It's simple physics, but the relatively complex design of the bomb itself allows it to work. The rigid tube of the barrel allows it to penetrate steel. It is extremely narrow to allow penetration and extremely heavy to help it gain speed from the air to be able to burrow. All of this means that the bomb can withstand and pierce through the Earth's surface, which is exactly what's needed to get into and destroy the bunker below. This massive bomb is typically carried in an aircraft like a B-2 stealth bomber or an F-111. In a typical mission, intelligence sources or aerial satellite images reveal the location of the bunker. Once dropped from the plane, it gathers a huge amount of speed. This helps it to build up kinetic energy as it falls on down. Upon hitting the ground, it impales straight through the surface with its nose like a knife through butter. The last part is a delay needed so that the bomb doesn't go off at the surface. This is done by using a delay fuse or a hard target smart fuse so that the bomb doesn't blow up prematurely. Research into these fuses has shown that using a microprocessor or an accelerometer, an operator can actually detect what is happening during penetration and explode at exactly the right time needed for maximum destruction. The effect of these bombs can be devastating. They can be dropped from 20,000 feet in the sky. Tests showed that when this was done, the GBU-28 bomb was able to pierce through 100 feet into the ground and 20 feet of solid concrete. Since the original bunker blaster, there have been developments to go even deeper and cause even more destruction. The way this is done is with 3 options. Make the weapon heavier. This gives the bomb more kinetic energy when it hits the target. The weapon could be made smaller in diameter, which will allow more penetration into the ground. Then there's making the bomb move faster through the air, with the only realistic way of doing this by adding a rocket to it. Since the original bunker blasters, there have been plenty of modifications made to make these weapons more effective. This has culminated in a giant bunker blaster being made available to the US Army, known as MOP, or Massive Ordnance Penetrator. It's a huge bomb that works on the same principle as the original bunker buster. The bomb is 20.5 feet long with a diameter of 31.5 inches, but it weighs a huge 30,000 pounds, well over 6 times more than the original bunker bomb. Most of the weight comes from a steel casing that can reportedly penetrate up to 200 feet of concrete that's reinforced at 5,000 pounds per square inch. The secret to the bomb's effectiveness is its weight rather than its explosiveness. Only a fifth of the bomb's total weight is thought to be the thing that does the damage. This huge weight gives the bomb the energy to burrow into any bunker. The kind of places that this bomb would target include the underground command and control sites in countries such as Iran and North Korea. Both nations have nuclear research facilities kept hidden from US forces, and clearly the country wants to be ready in case fighting does break out. If it does, then the MOP is likely to be able to do damage to anywhere that it targets. Bunker bombs are a great example of how simple physics can be used to penetrate targets that were previously thought to be impenetrable. The original bomb made its first appearance over 30 years ago, and development since then has only made the bombs bigger and more capable of busting through massively thick defenses. A combination of strength, weight, and explosiveness make the bunker bomb the most powerful non-nuclear bomb known to man. What do you think about the bunker bomb? Let us know in the comments, and please like this video if you've enjoyed it. Thanks for watching.